Hello my dear students and welcome to this part 2 video of chapter 16 electric current and its chemical effects class 8. Students, in the part 1 video you must have enjoyed the activity. In the activity we have used the continuity tester to check the liquids whether they are electrolytes or non-electrolytes. So what we have studied that liquids can be categorized on the basis of electrical conductivity into two types, electrolytes and non-electrolytes. Electrolytes, we find out that the bulb was glowing in the continuity tester, whereas in the non-electrolyte, the bulb was not glowing. Electrolytes, that means they are conductive. Non-electrolyte, they are non-conductive liquids. Electrolytes, that means if they are conductive, we have discussed that they are ionic. Non-electrolytes, they are non-ionic. Why they are called ionic electrolytes? Because they have free mobile ions. Non-electrolytes, they do not have free mobile ions. And the examples we have taken in the electrolytes are salt solution, acidic solution, basic solution, and for non-electrolyte, we have taken oil, distilled water and glycerin. In this part 2 video, we will basically understand what is the real cause of conductivity of electricity in the liquids. Students, as we have already discussed that the electrolytes, they conduct electricity and the non-electrolytes, they do not conduct electricity. The reason is presence of free mobile ions. So that means in electrolytes, there is presence of free mobile ions, whereas in non-electrolytes, there is absence of free mobile ions. When we are talking about the presence of free mobile ions, then there is need to understand that the free mobile ions in the electrolyte, it can be exist or they can be present. The free mobile ions can be present only in the molten form or in the presence of water. In molten form, when the solids they are heated, like if we are heating the salt, sodium chloride, and we are melting it, then after melting the salt, the sodium chloride, it will break down, or we can say it will decompose, dissociate or ionize to give us the positive and negative ions. Similarly, when we have the sodium chloride or any acid like hydrochloric acid and base, in the presence of water, these three, they will be breaking down or ionizing and decomposing or dissociating to give us the positive and negative ions. These free positive and negative ions, which are mobile, they are helpful in conducting the electricity through the liquids. That is why the liquids, they are electrolytes. Whereas in non-electrolytes, there is absence of any such free positive and negative mobile ions. That is why they are non-conductive and non-ionic. We have example over here. We have studied as earlier also the example of distilled water. Distilled water is said to be non-electrolyte because it is non-conductive and there is absence non-ionic and there is absence of free mobile ions. But to make it conducting or to make it electrolyte, what we can do, we can add a pinch of sodium chloride, that means any salt, or any few drops of any acid or base into it. When we are adding the salt, acid or base to the distilled water, then in the presence of the water, they will break down into the positive and negative ions, which are free mobile ions, and distilled water then in that case will become conductive and then it can be called as electrolyte. Now students, moving ahead with the topic, we know that the electrolytes, they have the presence of the free mobile ions to conduct electricity. On the basis of this, we can classify electrolytes further into strong electrolytes and weak electrolytes. Strong electrolytes undergo complete ionization, whereas the weak electrolytes, they undergo incomplete or partial ionization to give us free mobile ions. This means that if we consider the strong electrolyte just like sodium chloride or common salt, and if it is put in the water, then the sodium chloride, it will completely ionize to give us the sodium ions and the chloride ions. Sodium ions are the positively charged ions and chloride ions are the negatively charged ions. So these ions are available to us in large number because of complete ionization of the NaCl, and that is why the sodium chloride solution or the salt solution, it is categorized as a strong electrolyte. And in this case, if we test it with the continuity tester, the bulb will also glow with more brightness. Whereas if we talk about the weak electrolyte, in weak electrolyte, if I take the example of acetic acid which is present in the vinegar, then in the presence of water, it will not undergo complete ionization. Only few molecules of the acetic acid will undergo the ionization. That means the ionization is incomplete or partial, and it will give us the negatively charged acetate ions CH3COO- and the positively charged hydrogen ions, that is H+. So that means now we have a very less number of ions, free mobile ions available with us in case of weak electrolytes due to partial ionization, and that is why they are categorized as weak electrolytes. And that is why in the continuity tester, the bulb will glow with less brightness. So that means the electrolytes can be further classified as strong and weak on the basis of the ionization. If it is complete ionization and it is giving a large number of ions, then it is a strong electrolyte. If it is incomplete or partial ionization and giving us the lesser number of the ions, then we will classify it as the weak electrolytes. Examples for strong electrolytes are seawater, nitric acid, copper sulphate solution, sodium chloride solution, and sulfuric acid. Weak electrolyte, we have the example of ordinary tap water, oxalic acid, carbonic acid, citric acid, acetic acid, and ammonium hydroxide. So today we have studied about the cause of conductivity of the liquids and about the strong and weak electrolytes. I hope you have understood the topic well. Thank you for watching.